Those of you that don't know me, I'm Michael Paletta. Next year will be my 40th year keeping reef tanks, which means I'm a really old guy. And I've been friends with Sanjay for now 35, 36 years. So that makes us both really, really old guys. Now, one of the interesting things that we have learned is we don't know as much as we typically think we know, or we get very lethargic. A fish dies or a coral dies, and you ask them, why did that die? Well, I don't know. So, as I said, I've been doing this a long time. This is my reef tank in the mid-1990s. As you can see, I was keeping SPS under halides. This was my tank in the mid to late 2000s. This is my current reef tank with lots of fish and lots of corals. This is my a soft coral tank that's out in sunlight. And this is my LPS tank. So unlike Sanjay, who basically finds a method and sticks with it, I'm a tinkerer and an experimenter. And that's one of the significant areas which we differ. I'm always experimenting and trying new things. Now, there are good and bad aspects of that. One of which was, during COVID, I had lots of free time, as we all did. So as a result of that, I started doing a lot of experiments on the tank to find out whether, feeding the tank a certain food or changing the light spectrum did something. But the biggest thing I found was, don't do experiments all the time. The corals do not like instability. So from there, I have taken it a step further to try and find out why things die. That instead of doing experiments, I try to determine what is a negative factor that's caused problems in a tank. So whether you have a big tank like Andrew Sandler's 17,000 gallon tank, a small tank like Tony Plaster's nano tank, or a really little tank, you need stability and you need to try to figure out everything that's going on in the tank. Because corals don't lie. Corals are happy and thriving or they die. There's really no in between, and you can really see that what healthy corals look like and what dead or dying corals look like. It's not a secret. Now, one of the things that drives me crazy are these corals. These are internet corals. They're super saturated and really colorful. People buy them and think they can get those kind of corals in their tank. That is very difficult because a lot of times you don't use the lighting or anything like that. And as a result of this, a lot of these corals have become very, very, very expensive. But you don't need very expensive corals in order to have a successful tank. This is the difference between a supersaturated coral and a coral under normal light. Obviously, the one on the right is worth a lot more money. It's the same coral. This is a coral under supersaturation and bright light. This is what I call a blue hand coral. Blue hand corals are typically the most expensive corals you can find, but unfortunately, most of us actually have this colored hands. This is what the corals actually look like. They're not the same. So if you're buying blue colored corals, odds are, and you're trying to get them to look like that, you're going to lose out and those corals are going to die. That's one of the reasons. We're not born wearing orange glasses all the time, and we shouldn't have our kids wearing orange glasses to try and get this kind of look. Corals are beautiful whether they're brightly colored under blue lights or in Sanjay's case under all his LEDs at 100% all the time. They're awesome looking corals. How much can they manipulate a coral? This isn't even a coral. This is an anemone. This is the same coral on the left as on the right. I almost purchased the coral online on the left until I asked them to show me it underneath normal lighting. This is what it looks like. It was not worth $400 whenever I saw it under the normal light. When a coral costs approximately the same as a divorce, there's a problem with the hobby, in my opinion. So keep that in mind when you're purchasing the $400 frags, that this is what you can get a divorce for. Now, one of the interesting things I found is we all have this same tendency. We have a wonderful, happy, thriving tank, and one coral dies. What do? We try to manipulate and move the whole coral tank around to try and make it fix this one coral that died, rather than looking at all the corals around it that are surviving. All the corals we put in the tank don't come from the same place, aren't under the same conditions, and sadly, all of them aren't going to survive. You have to keep this in mind. Corals die a lot of times, particularly new ones, when you add them to the tank. If you had smaller frags, they typically do worse than larger frags. In the mid-1990s, a gentleman named Dieter Brockmann in Germany and I did a similar experiment. We looked at frag size and survivability. He took 4 frags of approximately a quarter inch. I took 4 frags of a quarter, a half, 3/4, and 1 inch. Guess what? The frags at a quarter inch had approximately 25% survival rate at 6 months. The half inch had about 40 to 50%. The 3/4 inch had about a 70%, and the 1 inch or bigger had almost a 90% survival rate. So it was very simple, but the thing we learned was once you put them in the tank, not everything is going to survive. How do you tell a coral is thriving and going to survive? First thing you want to look at, do you have nice growth tips? The purple ends on this Reef Raft Ultimate Orange Passion, I hate names by the way, but I remember this one, is when you have nice growth tips. When you have growth tips going on in your corals are traditionally thriving. By the same token, when they're encrusting down like this, they're also thriving. Those are the 2 simplest things to look at of when your tank is surviving and when your corals are doing well. Look at just those 2 factors. Manipulating and changing things all the time. I have had corals that didn't have growth tips literally for a year. They were growing, but they never had the growth tips. So that was one of the things that I've worked on, is to try and maximize the growth tips because it maximizes their survivability. Same token, when corals are very colorful, these are not manipulated corals. I didn't use filters, I didn't do anything. This is how brightly colored these corals are under blue lights. That also gives you a tip that they're thriving. Now, when you look at the overall focus, there's a number of factors that are critical. All of them are important, but it's like a pyramid. If you don't have a strong base of the pyramid, the typical pyramid will fall down. The typical base of the pyramid is starting with pure water. Most of us know to start with RODI water. Why? It's clean and pure. Over the past few years, a lot of municipal authorities have started dumping a lot of junk in the water. I know of at least half a dozen hobbyist friends that have lost whole tanks of stuff because their RODI unit either got burned up too quickly or they didn't change it often enough, or they didn't test for it. So in addition to testing for your water and your tank's quality, you have to test for the water coming out of your RODI unit to make sure it is of high quality. Next is salinity. This is one that we often take for granted. I have seen a lot of people, particularly new and intermediate hobbyists, using the old swing arm hydrometer. That's basically a toy. It is not, I'll never forget, I used to go to Aquarium Systems when they were the first ones to do the swing arm hydrometer, and they would have 100 hydrometers out with saltwater, and literally none of them had the same arm. And I said, why do you do that? He says, well, if they're within 5% of each other, those are the ones we sell, the rest we throw away. This is not a good way to measure the salinity in your tank. This is all the different equipment I bought. I know you're saying there wasn't a refractometer up there. That's because this is how I look at a refractometer, to try and see that little line of the numbers. Granted, I'm old, but I don't know anyone that can readily see that number, so I have quit using a refractometer. I then went to these Hanna salinity checkers. The ones on the left were when they were calibrated. As you'll see on the right, they're different. They're one number different. They were literally just calibrated 30 seconds before. All the electronics that you use to calibrate salinity need to be, or all the monitors you do to measure salinity need to be calibrated, and probably every time. Consequently, like Joe, I have gone to the old classic hydrometer. Unfortunately, as with a refractometer, the lines on the hydrometer are so small you can't see it. Fortunately, with new technology, the new iPhone, I can take a picture, then look at that and blow it up and see what the salinity is in the tank. This is what I now use. It's stable. The only thing I worry about, I have 2 of them because I know down the line I will break the neck off this thing, which I have done literally dozens of times. Next comes major trace elements. The 3 biggies: alkalinity, calcium, and magnesium. These are the Hanna test kits. And to be honest, these are not quite as reliable as I would like. Basically, I have found that if you just use RODI water, particularly for the calcium and magnesium test, they will be wrong. You have to use distilled water, because even literally parts per million of calcium, because you're using so little water sneak through, your calcium levels are typically up by 50 points. Same with magnesium. Now you can use regular test kits. I have gone to using ELOS kits simply because they're easier to read. I can see when the color changes. The problem I have with most test kits is it's very difficult to see the color change. As Sanjay pointed out, you couldn't tell on nitrate going from 20 to 50. It's not like a drastic difference. So I use the HANA test kits for that. Then we get to the major elements. These are the major elements in the tank. These are the ranges that you traditionally want to be at. Now, one of the things I also did during COVID is I contacted literally every week 20 of the people that I thought had the nicest tanks that I knew of in the US, and I gathered all the data from them. When I say all the data, it's roughly 40 pages of data from their tanks. It shows everything from what their alkalinity levels were, calcium levels, and everything else. I then took those numbers and averaged them, and these are what the average numbers of these people that had really successful tanks were. So I didn't want to just be, okay, these are different than normal seawater. That's a given. A reef tank is not the ocean. A reef tank is a closed system that is significantly different than the ocean. Unless you have Joe's 20,000 gallon tank, all these other tanks are significantly smaller and significantly different. So I went to the source for the people that have successful tanks, and that's where I pulled these numbers from. Now, of those numbers, the one I feel is the most important in alkalinity, and that's the one that traditionally changes most quickly. I use an alkatronic monitor. I measure my levels every 4 hours. I have it hooked up to a dosing schedule. If my numbers go plus or minus 20, I can dose or I can reduce the dose. So I can do that literally from here. So I keep the alkalinity right at 8.0 now. I used to keep it higher, but I found that was more problematic when I kept it higher. You can run a calcium reactor. It works very well. The only problem I have with it is it tends to dump a lot of lower pH water into the tank. And I've become a big advocate for keeping the pH higher. So low pH, which I'll discuss later, can be a potential cause for the demise of some of your corals. This is my simple dosing system. You can see the chemicals are in the bottom and Kermer pumps up above. Everything doses in, everything can be controlled from when I'm away from home. So everything is monitored and checked all the time. As long as you keep your alkalinity fine, no problem. When you get a sudden spike like that, typically you don't see a problem in the next day or two. Typically you see the problem a week, 10 days, 2 weeks after this spike. So that's one of the reasons why I strongly suggest you keep a log to help determine what's going on in your tank. So when something dies, you can say, okay, what happened within the last month that may have resulted from it? Very rarely, unless you do something really badly, do your corals die overnight. Most of them take a long time, a week, 2 weeks, something like that. But if you haven't kept track of where things are and what's going on in your tank, you have no way to be a sleuth and go, did I just have an alkalinity spike 2 weeks ago? When you keep a log of things, it pays off. Now the next thing along with alkalinity and keeping the alkalinity stable is what effect does pH have? Bulk Reef Supply a couple of years ago asked, does raising the pH of the tank increase calcifying coral rates? The answer was yes. It increased it by approximately 50%. Now, since most of us want to grow healthy corals, and when corals are growing quickly, they tend to be more colorful, the two run hand in hand. Conversely, if you have a low pH, you can still grow corals, don't get me wrong. I know people growing corals very well at pHs of 7, 7, 7, 8, but you have a higher risk of causing a demise of corals, which I'll talk about in a minute. My pH runs an average between 8.1 and 8.4, averages around 8.3. Now, how does it do that? One, like Joe, I'm back to using good old Kalkwasser. For those of you that don't know what Kalkwasser is, it's calcium hydroxide dissolved. There's a spinner on the bottom that spins 4 times a day, puts the calcium hydroxide into solution. My makeup water drips into it gradually throughout the day. I never dump more than 100 milliliters at a time into the tank. That has helped to stabilize the pH in the tank. In addition to that, you have to keep the CO2 levels in your room and around the tank lower. This is a cheap CO2 monitor I bought on Amazon for like 35 bucks. It tells me exactly what the CO2 levels are. Why is this important? If you have high CO2 levels in the room, when you're agitating the water, the surface agitation is acquiring the CO2 and dissolving it in the water. That's why we're worried about calcification in the ocean, or acidification in the ocean, reducing calcification. Consequently, I try to make sure that the CO2 levels in the room are always low. Normal CO2 outside is around 425. My room stays around 600 to 425, which is fine. Once I get over 800 to 1,000, I'll see the pH gradually creep down in the tank, slowing the growth rates in the tank. So one of the other things I do is I open the window. I live in Pennsylvania. Unlike here, where it's 1,000 degrees, for at least 6 months a year, it's reasonable temperatures up there, so I can keep the window open, and usually there's a fan there either blowing air in or blowing air out to keep the CO2 levels in the room down. Because what happens is, when you reduce pH, you also reduce the microbial balance around the corals, leading to more disease and also leading to slower growth rates. Consequently, I try to keep a higher pH, as I showed you. And in talking with a bunch of other people over the last year or two, a lot of other people are now trying to keep their pH much higher as well. In addition, there's indications, as I said, that when you lower the pH, you're slowing the calcification rates. So that's one of the reasons: slower growth, slower calcification. Next thing to look at is why your corals died is looking at the dynamic elements. When in talking with a gentleman named Claude Schumacher of Modern Marine, these are what he considers the 5 dynamic trace elements, the five crucial trace elements. There's actually one more that I found crucial. What's interesting is he wants these to be on a stable level. That is, they're all approximately that middle blue line. Even copper, which sounds crazy. We all know that copper is a killer. But copper, in his findings, and he has run over 200,000 ICP tests at his facility and has over 20,000 gallons of corals being farmed. He has a pretty good idea what he's doing. He found that as long as those levels are good, everything's fine. But if your copper level's high or the other ones are low, that's when you run into problems. So with these dynamic elements, you want to keep them right on that center level. So this is what the ICP evaluation shows, is how are these in balance. Now there are a lot of trace elements out there. Now for virtually everything that's out there, I am currently using them. Can I say I've seen a dramatic impact where everything just took off overnight? No. It took about 3 months till I started to see any kind of impact of using these trace elements. And you're not adding large quantities, you're adding small quantities of these. Because what you're trying to do is keep things in balance. Now after the trace elements, the next thing you want to look at are your nutrient levels. Now, most people I know try to keep their nitrates, or looking at the 20 people that kept their nitrate levels between 5 and 20, and their phosphate levels between 0.05 and 0.1. What's interesting is, as I said, I had an infinite amount of time during COVID, so I started looking at the ratios between these. And what I found was important. The people that had the most colorful corals in the group kept the ratio of at least 50 to 1, and in the best case, over 100 to 1. So in our estimation, the ratio was critical. What's interesting is last year at MACNA, again, I was talking with Claude about this because we were trying to figure out what's crucial in terms of nutrient levels and algae. He said he had found the same thing, that 100 to 1 seemed to be the crucial ratio of nitrate to phosphate. So since then, that is what I now keep. This is Sanjay's tank approximately 2 or 3 years ago. His phosphate level was 0.61, his nitrate level was 90, and his alkalinity was 9.5. I will give you $1,000 if you can find even a speck of algae in this tank. There was none. I mean, this is the checker showing the 0.61. This is how healthy and happy those corals were doing that. Sanjay is also unique in that he runs his Ecotech lights at 100% every channel for 9 hours a day. So when you run high nutrients and high alkalinity, or when you run high lighting and high alkalinity, you need to run high nutrients as well to grow the corals. Because one of the things that they have found is limited phosphorus. You can't have the phosphorus at 0 and expect your corals to be healthy and growing. He spoke about nitrogen and the need for corals to have nitrate or nitrogen in order to thrive. They also need phosphate in order to thrive. Phosphate's part of the protein matrix that makes up the corals. Uh-oh. Oh, there we go. Some people keep their numbers significantly lower. And this is the lower numbers for that tank growing algae. As Sanjay said, sometimes you can have really low nutrient levels and still grow a massive amount of algae. The question is, okay, when you're growing a lot of algae, typically that will smother the corals, particularly this hair algae that grows over everything seemingly in minutes. If we could grow this to feed animals, we would have no shortage of food for feeding animals and feeding humans, because this stuff grows faster than anything. So once again, I got back to the secret sauce. This is an article I wrote on what we found from these 20 people's tanks. And it basically said there is no secret sauce. It's all stability, managing these trace elements, managing these nutrient levels, and building the pyramid slowly and gradually and not trying to do it overnight. Now, as I said, one of the key ratios is nitrate to phosphate, but there's also some other ratios that are critical for keeping the corals healthy. One of which is the bromine to iodine to fluoride levels. If your bromide and iodine levels are high and your fluoride level is low, that's when you typically get brown corals. And when you get brown corals, they're typically not doing as well as the brighter, more colorful corals. Consequently, I found out the number that you want to have your fluoride level at, and not all ICP tests measure for it, is around 0.80. My fluoride level was 0.31. And at least half of the corals in my tank did not have growth tips and were brown. Over the course of 3 months, I've gradually gotten my fluoride level up to 0.85. Now I'm having really nice growth tips. I'm getting much faster growth, and all of the corals that were brown have regained their color. So I've become a strong advocate for looking at the fluoride levels in your tank. The other thing that will potentially harm your corals, sometimes killing them, but sometimes causing them just to not look good, is by having your potassium level too high. That is, when I say too high, greater than what your calcium level is. You want to have your potassium level at least 20 points lower than your calcium level. There are tests for this, and it shows what you need to keep that at. And as Sanjay pointed out, one of the ways to do this is by doing water changes. I do 10% every 2 weeks on a 500-gallon tank. That keeps things relatively stable. But one of the things I suggest you also do is you test your makeup water. Test the salt water you're going in, see how close it is to what your salt water is going into your tank. In the old days, I used to rush when I added the new salt water into the tank because my corals were exposed to air. Now my corals are below the water. All the water change happens in the sump. So now I also gradually add the new water into the tank. This has also reduced the shock on the corals and helped them do much better. As I said, stability is the crucial thing in this. So now instead of taking 20 minutes to dump 50 gallons of water into my 500, I now take 5 hours to add it into the tank. So it's slowly mixing in with the tank water, and that's reducing the shock and increasing the survivability of the corals. So this gets us back to minor trace elements. These are the little tiny elements that make up less than 1% of the trace elements in the tank. These are what they are. And each of them has different properties that are beneficial. But until you have that pyramid built and you've gotten to the top and you do your ICP tests, you're not really going to see a whole lot of benefit. If your tank isn't thriving and you start dumping in trace elements, it's not going to change anything and make it better. If your corals are dying and not showing bright coloration, look for everything else on the pyramid before you get to the trace elements. Do your ICP tests and find everything. In terms of what I've done to try and analyze and how beneficial trace elements are, I looked at this Coral magazine that gave the most extensive review of trace elements I've ever found. And then I also went on Fauna Marin's site. These are the various trace elements they assess. You can pop any button there, and it will give you a one-page explanation of every trace element, what it does, the level you want to keep it at, what the ratios are, and everything else. This is critical if you want to get into using trace elements. You don't have to on your tank to be successful, but if you want to take it to the next level, this is one of the things you may look at. Even something as simple as vanadium. It talks about everything going here, but it even talks about what the skill level are for people that are using it. Red only, experienced hobbyists should only be people trying it. As I said, you can now get trace elements of just about everything you want in a single entity, and I like those better than the old mixes. Because we now have ICP tests, you can tell exactly what the levels are of everything in your tank, and there are calculators that tell you, okay, you need to add 10 milliliters of this, you need to add 40 milliliters of this up front. Everything is done for you up front, so you're not overdosing, you're not poisoning the tank. I don't know what's in here. I don't know what the concentrations are in here. I don't know what the ratios are in here. You know, one's for coloring red. Okay, I don't know what that means. So I have gone away from using this and gone toward the individual agents. Again, corals don't lie. You have healthy, bright, colorful corals, you're doing something right. One, don't change it, because that's one of the other reasons we kill our corals. We're always incrementally trying to make things better. I'm someone that has done this for the last 40 years. I will tell you, it does not work. Don't try to constantly be changing to make things, because you read something online, or you saw a picture of something, go, I want my coral to look like that. Remember the first couple pictures I showed you, that bright colored coral? Photoshop, oversaturation, filters, everything can be done to make a coral look like that. If your corals are happy and colorful, stick with what you're doing and don't constantly be changing and try to make things slightly better. This is ICP testing. ICP stands for inductive coupled plasma. It's basically you burn the water and then it reads what the light looks like for each chemical and tells you what the concentrations are and the levels. It works for a lot of the chemicals. It does not work for fluoride. That's why a lot of the ICP tests do not use it. They have to run a completely different test to run for fluoride. But then it allows for you to check out the concentration of each and every element. We didn't have that up until approximately 10 years ago, and they really haven't refined it until the last couple of years. When I say refined it, there are a lot of ICP tests out there. There's actually 2 more out there. In January, I ran 7 of these simultaneously. I sent in 7 tests. Amazingly, none of them were the same. Shock. But on a lot of the major elements, they were very close. It's where on the minor elements that they differed significantly. So they're good on big things, phosphate, nitrate, strontium, potassium, and a couple of others, but they're not so good on some other ones. So I have gone to using ones that, 1 show fluoride, 2 that I saw were consistent, and 3 that measure everything. The problem I had with a couple of them, most of the minor trace elements come back with an NS. They couldn't find any. That's not beneficial for me when half of the trace elements they came back with showed they couldn't find it. The reason for this is some of the older ICP testing is either based on seawater or salt water that they mixed up or natural seawater. The newer, better tests are actually run on aquarium water. They were balanced and calibrated based on aquarium water because that's what we have. We're not running seawater. We're running aquarium water. It's significantly different, as I pointed out. The other thing that's different with these is they can show the ratios between them. A lot of them just show, I have this level, this level, this level. Some of the better ones show what the ratios are and what the potential is for having to adjust these to get that ratio in balance. So that's one of the things that look at when you're deciding on an ICP test. This is what a typical ICP test looks like. Needless to say, mine was not perfect. Those big red streaks going straight up into the air on the right, those should all be near the blue line. When you get things like that, something is off balance. What's interesting though is, in talking with a couple of the manufacturers of the ICP test, when I asked how many of the people that send these in have everything straight on the line, it's less than 1%. So you're always going to be trying to balance these to get things right, to get tanks like look like this. This is a gentleman named Andre Mueller's tank. He's the guy that sells Reef Moonshiners trace elements. This is what his tank looks like. I'm a firm believer in look at a person's tank. If they have nice tanks, those are the people to listen to. Now, unfortunately, there is actually very little proof that show that trace elements have any impact. In that, from looking at the scientific literature, I could not find anything that says this coral takes up cobalt more than this coral takes up strontium. There's virtually nothing out there on this, that corals consume trace elements directly. But there is a lot of literature showing that bacteria take up a lot of the trace elements. And believe it or not, the main thing that corals eat is not the coral foods that we're throwing in, it's the bacteria that's around them and that's on their coat. Consequently, when they put in the trace elements, you're probably feeding the bacteria that the corals are going to consume. So they still get it, but it's secondarily. So it's not going to, and that's part of the reason why it doesn't happen overnight. You add these things, it takes a while for the bacteria to consume them, put them into whatever structure they're in, the corals then consume the bacteria, and then to change things that way. This is a tank well managed with trace elements. Again, but trying to do so, like I said, is like balancing the plates on a stick. Most of you aren't old enough, they used to have guys on TV during a variety show that would do this plates on a stick thing, and that was entertainment in my day. So just to give you an idea. So these are the 5 main trace elements that I add to my tank, from which I've seen a significant impact. Fluoride, as I told you, the interesting one though is manganese, particularly for gonioporas and for getting coloration in the corals. When I ran out of manganese for a couple of weeks and didn't add it, I could see the coral's coloration gradually diminishing. So I knew that it was having an impact. I was also watching some of the gonioporas, polyps pull back. So a couple other people have said the same thing. Manganese seems to be one of the corals that seems to be crucial for coloration. The trace elements are crucial, but they can also be crucial in terms of having an impact on tissue necrosis. More and more people have talked to me about having STN or RTN in their tank, which are actually 2 different diseases. Tissue necrosis is one of the banes of the hobby. And there are a lot of factors that can cause it, from instability, which I talked about, high temperature, inadequate flow, high CO2 and low pH, excessive amount of amino acids can all lead to different tissue necrosis. There's RTN, which the tissue just seemingly sloughs off. So a lot of people, this seems like a new disease. It's actually been around since like the early 1990s. I used to fly out from Pittsburgh to California to bring back corals from a guy named Leck at Aquatic Depot who was bringing in Fijian SPS corals. And I would go there, and when you'd walk into his facility, you could tell if the corals were good when they came in on Wednesday or bad, because there was this sickeningly sweet smell when they were bad, and they would all undergo RTN. It's a smell you can never get over. You could smell them in the bags, in the box. That's how bad it was. This is what it looks like. It starts in the upper portions, branches out. You'll have a healthy coral over here, a dead coral over here. Basically what we did, we either cut off the dead part and started fragging it. That's literally when fragging started doing this, because we were trying to save the mother colony from the RTN. Nowadays, it often occurs, when it's occurring, a lot of people are still adding carbon sources. I use the cheap vodka. Sanjay uses Absolute. I use Banker's Club because it's only $9 a bottle. Or amino acids or reef nutrition. Any of these coral type foods can fuel tissue necrosis. So if you're starting to have tissue necrosis, you need to stop dosing these. Now, what is the cause of tissue necrosis because of this instability? The corals are stressed. Some have proposed that it's ciliates, because they took the ciliates off some of the sick corals and put them on corals and found that they caused a problem. This is what the ciliate looks like. This is the good old days. This is the mid-1990s. This is my tank under halides and under kalkwasser. Guess what I really never had in that tank? STN. The halides were probably doing something. The higher pH was probably helping the corals fight off the pathogens, because a low CO2 environment causes the coral mucus to allow pathogenic bacteria to be more prevalent. Consequently, you need to keep the pH higher and the CO2 levels lower, because otherwise the pathogenic bacteria have a better chance and the corals are stressed. So what's happened and what we're finding is that coral bacteria communities are way more important. We're only now starting to look at the microbiome around a coral and understanding how important keeping that healthy is. Just like keeping the lining of your mouth or anywhere else where there's mucus involved is critical, same thing with the corals. Oop. That's why one of the things that a lot of scientists are now analyzing is coral microbiomes out on the natural reefs, and they're using that to help predict which corals are going to be able to survive raising ocean temperatures, which aren't. And the same thing is true in our tanks. You can look at these biomes and you can look at your CO2 levels and other factors, and you can assess how healthy are the corals based on this. Now, these are some of the trace elements that if they're low, you will find higher likelihood of having STN in your tank. Strontium strontium and fluoride are two of the more critical ones, in that one of the things I've found in talking with the people that have had these STN outbreaks, just talking, whenever you have these corals, how easy are they to break? And what we found is they literally are as brittle as any corals that we've ever had. So what happened was most of these tanks had low strontium and low fluoride. Consequently, they weren't calcifying quickly, which led to part of their demise. The other cause for this, in my instance, was Vibrio. This is a breakdown from Aquabiome on the bacterial population in my tank. You can barely see the color, but my tank is on the left, a normal tank is on the right. If you look at that bottom red column, that's Vibrio. Vibrio is roughly 30% of the bacterial population in this tank. On the right, Vibrio should be about 10% of the population. In the early 1990s, I sent a sample to a friend of mine who runs the microbiology lab at the University of Pittsburgh with tissue samples sloughed off from this. What he found is it was Vibrio vulnificus and a couple other strains of Vibrio that were causing tissue necrosis in my corals. Well, after I saw this, I knew Vibrio was the cause again. And this is what Vibrio looks like. So unless you have a microscope and are willing to culture this and find it, the best bet is to send in a test to Aquabiome to find out if you're losing corals from STN from this. As I said, there are a number of factors that have been causing STN. I'm not advocating that you go out and treat this, but if you're having tick problems with STN, Vibrio is something you should look at. And this is why I had to go to a Cipro treatment. And it's only by pure dumb luck that I went to the Cipro treatment. I knew it was Vibrio, but I was still saying, I don't want to treat it with antibiotics. I don't want to go down that road. But I had a spathulata, an Acropora spathulata, which is typically a very difficult coral to keep long term. I'd had it for 3 months. All of a sudden, it was showing the symptoms of STN, where it was bleaching from the bottom. I gave it a dip in Cipro, took it out of the tank, put it in Cipro, 4-hour dip, rinsed it, put it back in the tank, waited for the next day for the STN to continue. It stopped. Waited another week for the STN to continue. It stopped. Waited a month, no STN. Unfortunately, 3 corals over, another coral started doing that. Dipped it, treated it, same thing, stopped the STN. I'm going, okay, I have something going on here. At that time, I went to ARC in Buffalo, New York, and I was talking with the owners, Devin and Randy, and I was telling them the problem I had. They said they had had a similar problem, and they went in and aggressively treated the tank with Cipro. This is what their tank looks like. This is an incredibly healthy tank. They showed me pictures of when it was dying. They didn't want me to share them because no place that owns a store wants to show you corals are dying. They said, this is what we did with Cipro. The dosage was 500 milligrams per 500 gallons. Okay, that's 1 tablet. No problem. At the same time, I was talking to Jake and I was talking to Chris Meckley, and we came up, they were starting to use oxalic acid to treat their corals. What is oxalic acid? It's in the same family of antibiotics as is Cipro. It's a quinolone antibiotic. It's just not as strong as Cipro is. Okay, obviously, these antibiotics work on that. Consequently, I went in and dosed the tank at 1 capsule every night, dissolved up. That's the nice thing. It dissolved very quickly in salt water. Dosed the tank every night, every other night for 10 nights, 5 doses, the bacteria stopped in the tank. After I treated, I did a water change, and then I started adding a lot of bacteria into the tank. Now, I don't advocate adding bacteria all the time for one simple reason. Actually 2 simple reasons. One, I don't know what's in their mix. They never tell you what bacteria in there. 2, on the back of the bottle, it always says, add this once a week, add this twice a week. Having worked in medicine, if a bacteria is going to be alive, it shouldn't die in 2 weeks. If it's doing something beneficial, it should take off and thrive. If these are good bacteria, they should be doing that. I should not be having to change out this bottle. I know they have to sell bottles of bacteria, but it doesn't make any sense. So I dosed with 5 different kinds of bacteria. Tank was stable. Another month, I did another test. Guess what? Vibrio was even lower than their standard. All the other bacterias, there was a much broader range. If you look at all the different strains that were in the tank, after killing off the bacteria with Cipro and then dosing, I got to this. The interesting thing was, I had no other issues in the tank. When I say no other issues, nothing died, the fish were fine, except for one interesting thing. The average redox potential in my tank is around 325 to 350. After this 10-day course of therapy, my ORP was 200. This antibiotic had killed off something that was adding oxygen. Whatever oxygen producing bacteria in the tank, it killed those off as well. So I added more flow in the tank, I added more surface agitation. It took another month, but after another month, my redox potential got back up to 325. But keep that in mind, that if you dose that, you probably need to improve the oxygenation in your tank, because it's going to bring it down, and that can be deleterious to the fish and corals in your tank. And this is why every coral in my tank gets dipped and every coral in my tank gets quarantined now, because I don't want the last thing in the tank to wipe out everything that's in there before. As I jokingly say, if I got frags from my mother, I would dip them now. So keep that in mind. Anything can bring in a pathogen into your tank. And I went over a lot of different things that can cause demise in your tank. There are also a lot of pests in your tank that if you're losing corals, you need to look for. On the left-hand side is a picture that Julian just posted of a Rappa snail. It's a snail that comes in about the size of a grain of rice. It bores into the base of a leather coral, then gradually expands. I once had a leather coral that was this big that all of a sudden started rotting at the base. I cut an incision in the middle of it, could smell the rotting, decaying tissue in there, opened it up even more, and pulled out that right Rappa snail that was the size of a golf ball. So if you're losing a leather coral at the base, this is something to look at. Similarly, Sanjay talked about the Astorina snails and how bad some of them can be, or Joe actually talked about them. This is what I pulled out of my soft coral tank. Most of them are good, but like that red one there, I'd also seen that on my pink Poeciloporus. The colors of these is what they eat. If they're beige or gray or brown, they're typically eating detritus and algae. If they're pink or orange or other colors like your corals are, that's what they're eating. So if you have those, you need to remove them either physically or add a harlequin shrimp. Similarly, there's a couple of new pathogens. Joe mentioned the one on the right, which are the amphipods, there are a number of different red bugs, black bugs, hopping black amphipods, his white amphipods. All of these eat your corals. And unless you look at them very closely, you're not going to pay attention and find them. So again, if you're losing corals for no reason and everything else is stable, look for pests like this. On the left is a torch coral. You can barely see them, but in that upper white portion is a section of eggs from a Euphyllia eating flatworm. So now we have flatworms that eat virtually everything in our tanks. So you have to keep this in mind. There are pests for everything that we can keep, and the better we get at this, the longer the pests have to thrive. This is my tank 5 years ago. So long term is what you're looking for here, and looking at what can cause things or cause the demise of your corals. I know I didn't talk a lot about fish and what potentially causes their demise. But if you have a lot of fish like Andrew Sandler does, I've learned a lot from him in terms of the need to quarantine everything. whether it's an expensive Pictilius anthias or even green chromis, everything needs to be quarantined. Green chromis are really prevalent for bringing in Uranema now. So if you have a healthy, thriving tank and you say, oh, these are only $1.99 fish, I don't care if they die. They don't care if they die either. What they will do is potentially wipe out all the rest of your fish in your tank. So keep that in mind. Quarantine and treat everything. And if it's a very expensive fish, you definitely want to quarantine it. One of the things I am working on with Andrew Sandler and Polar Reef is coming up with a sort of a Venn diagram of what antibiotics and what treatments to use for which fish, because not all fish tolerate all treatments and all antibiotics. Like wrasses, you typically have to deworm. Like anthias, one, you have to get them eating, but you also have to worry about what pathogens they bring in and what drugs they tolerate. The same thing with angelfish. Also, if you have a quarantine tank up, if you have a fish that develops bubble eye or something else, if you can catch it and bring it out, it's much easier to treat, and it typically has much long-term success if you treat it in a quarantine facility. And lastly, if you learned nothing from what I spoke about today, anytime you get a new fish, after you've quarantined it, do not just drop it into the tank, because it's like the new kid back coming to school. Everybody's going to pick on him, everyone's going to beat him up, and he's going to hide and be shy all the time. I use big plastic boxes. Everything goes in a box for at least 2 weeks after it's gone through quarantine. Sits up in the tank, everything gets used to it. I can make sure it's feeding in that water, it's used to that water, and it takes time, but it's more than worth it. Before, when I did that, when I would just drop the fish into the tank, I at best had a 50-50 shot that the fish would survive. And it was actually probably like 20 to 30%, to be honest with you. Now that I've gone to quarantining in plastic box, I have a 90% survival rate. So I'm much happier. It's something cheap, it's something everyone can do. Not everyone wants to do a quarantine tank. If you don't do a quarantine tank, at least dip them or do a quick treatment, but make sure you put them in the box. Then if they show any signs of anything, they're much easier to scoop out to try and get them out of the tank. I have literally spent days trying to catch fish out of my tanks. It's much easier after I put them in, and unless they're really beat up and they're hiding at the top, and you can scoop them out, in which case it's typically too late. It's much easier if you do this. Because one of my long-term goals is to be like Sanjay and someday have purple spotted filefish in my tank. When your corals are really thriving and healthy, come on, you can add some of these. He's had these for the last 3 years. Everyone's worried they're going to eat all his corals. He grows corals so fast, if you look at these small things, and we're fairly convinced that they're not only just eating the polyps on their corals, they're probably eating some of the predators of the corals as well, because they have a snout really good for going in between the crevices and pulling things out. So they're really beneficial if you have fast enough coral growth in your tank, which is the goal, rather than trying to figure out why your corals are dying. So as I wrap things up, this is a beautiful sunset in Positano, which if you ever get to go to Italy, I highly recommend you go and visit there. But the thing I hopefully will leave you with, whatever you do, whatever you like about this hobby, try to have fun doing it. A lot of us take this hobby way too seriously. It's about money, or it's too much stress. I've been doing this, like I said, for almost 40 years. I still have as much fun as I can doing this. And I develop long-term friendships. It's something like this, meet new people, talk to them, develop friendships, because it pays off when you have friends for 30 and 40 years. So that's all I have. If you have any questions, I'll be happy to answer them.